Okay, so that would be your final answer. Okay, any questions on that one? All right. Of course, now the sun comes out and gets in the way.
Can't help it.
Oh, of course it would help. It hurt the other day. Today it's helping. All right. Anyone still writing? All right. Okay, so we're going to go from that to addition and subtraction property. Of equality. Okay, so to kind of give you an idea of the concept behind it, instead of just jumping right to the definition, what if we let 3 equals 3? Okay. So we know there that that's true. Okay, so what if we go from 3 equals 3? What if we add 8 to both sides? So if we add 8 here and add 8 there, we end up with 11 equals 11. Which again is true. We haven't done anything but make one one equation convert to another equation that's true. But what if we decide, okay, now we're going to subtract 4 from both sides? Okay, so if we have 11 on each side and we subtract 4 on both sides of the equal sign. Okay, so that would give us 7 on this side and 7 on this side, which is still true. Oops. Okay. Now instead, let's say we just subtract 1 from the left side. Okay, so if we just subtract 1 from the left side, no surprise, we end up with 6 equals 7, which is not true. Or if we added 2 to the right side, it would still be not true. Unless you do everything to one side that you did to the other, that's the only way you can keep it as equal. Whenever you do something to just one side and not the other side of the equal sign, that's when you kind of throw everything out of whack. You can think of it like a leveled off seesaw. If you put the same amount of weight on both sides, it'll always stay level. If you put more weight on one side than the other, then it kind of tilts over. Okay. So that leads us to the addition property, or addition and subtraction property. Uh-oh. Let's say if we let the letters A, B, and C represent any number at all. Move that up a little bit. Okay. So that means if we start off with whatever A is equaling whatever B is, then as long as we add whatever C is to both sides, it will still be true. So then A plus C is B plus C. And A minus C is equal to B minus C. Because we did the same thing to both sides. We started off with something that was equal, and we just kept doing the same thing to both sides. Okay, so these are equivalent equations. Okay, and these two are equivalent. Okay, so both of these are equivalent to where we started off. If this is true, then this is true. If this is true, then this is true. All right, does that make sense? All right. Okay, so we're going to use the fact that if we do the same thing to one side that we do to the other, we're going to use that to solve any equation we want, really. This one thing kind of keeps on going. Okay, anyone still writing? All right. Okay, so let's say, for example, you wanted to solve, and you can probably solve it like right off the top of your head, but I'm going to show you x minus 7 equals 10. Okay, so using the actual addition and subtraction property, x minus 7 equals 10. If you have a minus 7 here, if you add 7 to both sides, then 7 and negative 7, those cancel out and you end up with 0. So those cancel out. So you end up with x equals 10 plus 7, which is 17. So all we did was do the same thing to both sides. If this would have been x minus 8, we would have added 8 to both sides. If this would have been x plus 4, we would have subtracted 4 from both sides. Anything to get rid of the numerical value, because all we want is the x value by itself. Does that make sense? All right. Okay, so let's say if we have, for example, if we wanted to solve x, let's say x minus 8 equals 43. Okay, so since we have x minus 8 equals 43, since that's minus, we're going to do the opposite, because we have to get rid of that minus 8. So we're going to add 8 to both sides. Minus 8 plus 8, if you add them together, they disappear because it just becomes 0. So x is going to equal 43 plus 8, which is 51. Does that make sense? All right. Any questions on either one of those? All right. Okay, so let's say, for example, we wanted to solve x plus 4 equals 26. Before we had x minus, which meant we had to add to both sides. When you have an x plus, you want to subtract on both sides. So x plus 4 equals 26. So we just subtract 4 from both sides. Move that up a little bit. Okay, so 4 minus 4, you add those together, you just get 0. So that leaves you with x equals 26 minus 4, which is 22. So just draw a little arrow there. Okay, so whatever the sign is, you're going to do the opposite. All right. So any questions on that one? All right. Leave that. that up there for a few seconds. Right. So what if we mixed it up just a little bit? And we wanted to solve y plus 8 minus 4 equals 19. So with this one, the first thing you want to do is you want to simplify any terms you can combine. So y plus 8 minus 4 equals 19. You just combine those two. Which gives you y, because 8 minus 4 is 4, plus 4 equals 19. So now you can just go ahead and subtract 4 from both sides. So you get y equals 19 minus 4, which is 15. Okay. Now, if you wanted to, you could have just subtracted 8 from both sides and added 4 to both sides, but it's easier to just combine them and do one subtraction. Especially when the problems start to get really long, doing each individual step like that can burn a lot of time. Okay, so any questions there? All right. Let's see. Oh. Let's say if we have to solve r plus 15 minus 8 plus 2r equals, let me get one that won't come out to be a fraction. Equals, I'll say 14. Actually, that's going to come out to be a fraction, but you don't have to add or subtract any fractions. And I'll show you how to simplify that 2r in 1 second. I mean 3r, thank you.
I probably do it wrong. Stress.
Actually, when you get to the 3r and you move everything else to the other side, just stop there. So it should be 3r equals something. If you already did it, then you're okay. Okay. So if you have r plus 15 minus 8 plus 2r equals 14, you can combine those two, and you can combine these two. Okay, so if you have r plus 2 times r, that's just 3r. r plus 2r equals 3r, because remember, r is just the same as 1 times r. Okay. So 15 minus 8 is 7. So r plus 2r is 3r. 15 minus 8 is plus 7. Uh-oh, why did I do that? Equals 14. Okay, so if we subtract 7 from both sides, we actually have the 3r by itself equals 14 minus 7, which is 7. Okay, now to solve this, we actually have to go to the multiplication and division property, which is pretty similar to the adding and subtracting property, is that as long as you do the same thing to both sides, it'll be an equivalent equation. So if we divide 3 on both sides here, remember, 3 divided by 3 is equal to 1. Anything divided by itself is going to be equal to 1. So this is what we're going to do next. So you have 1 there, so that's when you get r equals 7 over 3. So this is the division property of equality.
So in the homework, is you gonna want us to put it in like that or like an improper fraction?
That should be okay. They will probably tell you if they want you to convert it or not.
Okay.
They'll usually tell you. All right. So now we're going to go over that and the multiplication property. I'll leave that up for a few seconds. Anyone still writing? All right, looks like everyone's okay. So now we have the multiplication and division properties of equality. Okay, so just like we started off before, say we'll let 5 equal 5, which is true. Now if we multiply both sides by 2, that gives you 5 times 2 equals 5 times 2, which is 10 equals 10. This side is 10, this side is 10, so that's true. Okay. What if we multiply both sides by 4? We end up with 10 times 4 equals 10 times 4. Yep, which just gives you 40 equals 40, which is still true. Okay, so we know as long as we multiply both sides by the same thing, we'll get an equivalent equation, an equivalent expression. So what if we divide both sides, let's say by 10? Okay, so you have 40 equals 40. Going to divide this side by 10 and this side by 10. So that leaves us with 4 equals 4, which again is true. Now, if we did something to one side and not the other, then that's when you'll finally run across an expression that's not true. So if we did the left side by 2 and the right side by 3, or just the left side by 7, it would just all mess up. Okay, so if we have our multiplication and division property, let's bring that up a little bit. Properties of equality. again, we'll just let any number A, B, and C represent any real number. Okay, it could be 3, 4, 5, 7, 8, 9, decimals, fractions, any real number at all. If we know that if we start off that A is equal to B, as long as we multiply both sides by whatever C is, it'll still be equivalent. Equals B times C. And if we divide both sides by the same thing, it'll still be equivalent. So it can be A times C equals B times C, or A divided by C equals B divided by C. Does that make sense? All right. Slide through a little bit. Everyone's still writing. Oh, there you go. Okay, so let's say, for example, if you wanted to solve, let's say 2x equals 16. Okay. Now for the adding and subtracting, you knew that if you saw x plus something, you'd have to subtract whatever that number was. You have to do the opposite. Here, same thing. This is 2 times x, so you have to do the opposite to get rid of the 2, which means you have to divide both sides by 2. Whatever number's in front of that variable, that's what you're going to divide both sides by. So 2x equals 16. Divide this side by 2 and this side by 2. Remember, any number divided by itself is just going to equal 1. So that means if you have 9 divided by 9, that's going to equal 1. 20 divided by 20 is going to equal 1. 847 divided by 847 is going to equal 1. As long as you're dividing it by itself, it's just going to always equal 1. So we know that 2 divided by 2 is going to equal 1. So 1 times x is just x. So that leaves you with 1 times x, which you don't have to write the 1, equals 16 divided by 2. Yep, which is just 8, or x is equal to 8. Does that make sense? All right. Any questions on this one? All right. Let's say if we have to solve (27 times x equals 5). Okay, so whatever the coefficient is, that's what you're going to divide. 27 times x equals 5. So you're going to divide both sides by 27. Remember, you're always going to do the opposite when you're trying to get the x by itself. So if you see it's x plus something, you're going to subtract. If you see it's x minus something, you're going to add. If you see x times something, you're going to divide. If you see x divided by something, then you're going to multiply. So you're always going to do the opposite. Okay, so 27 divided by 27, remember, anything divided by itself is always going to be 1. So 1 times x. And again, you don't have to write the 1 times x. It's just kind of a visual I'm writing down. And 5 over 27, that's just a fraction you can leave like that because you can't simplify it. So it's just x equals 5 over 27. All right. Any questions on that one? Yes.
Just leave it like that, like the 27 by 5.
Yep, only if you can't simplify it anymore. We'll have the next example where you'll be able to simplify it after that. Okay, so for the next one, let's say if you wanted to solve say 4x equals 52. Okay. So if you have your 4 times x equals 52, did it hit you?
No.
No.
It's right there.
Okay, so now since you have a coefficient of 4, you just divide both sides by 4. Again, anything divided by itself is always going to give you 1. So x is going to equal 52 divided by 4. So 52 divided by 4 can actually be simplified. Yep, so 4 goes into 5 once. 4 times 1 is 4. Subtract, bring down our 2. 4 goes into 12 3 times. 4 times 3 is 12. Remainder of 0. So your answer is 13. So 52 divided by 4 is 13. All right. Does that make sense? All right. Everyone's due, right? Looks like everyone's. Okay, so what if we have to solve? Say y, oops, clean that up a little bit. Oops, here we go. Y over 3 equals 9. So y divided by, oh, sorry about that. Y divided by 3 equals 9. You have to figure out what y is. Okay. No problem. So the one good thing about this is it's just divided by a number. And you know that when you're dividing by a variable, to get the variable by itself, you want to multiply both sides. So if you're dividing, you're going to multiply again. So, y over 3 equals 9, which means you multiply this side by whatever your denominator is. So since your denominator is 3, you multiply this side by 3 and this side by 3. Okay. So really here, you can just go ahead and cancel these two out, and the reason that works, that seems like there we go. Is if you multiply this side by 3, 3 times y over 3 is just the same as saying, well, remember that 3 is the same as saying 3 divided by 1. Okay. You don't have to go through this step each time, but it's kind of showing you why it works. So it's 3 over 1 times y over 3. So if you multiply that, it gives